Guys, I'm Abrar, Director of GATE PATHSHALA. Me, Krishna and Anmol, three of us will be taking the entire course. So we will be starting from the very basic topics of multiple variety of different topics. All small basics we'll cover up. And then we will look into something like what it is called the core of aerospace engineering. Okay. I warmly welcome all of you, and those who are missing, you'll be able to get the recording after the lecture is done. We will release it on the YouTube directly, and I'll share the link with you. Okay. So in case if you miss the class, surely you have to raise a request for the recording to be shared. Okay. Fine, guys. I'm switching to the screen sharing. I'll stop the video and share the screen with you. Hope the screen is visible to all of you. Everyone?
Yes, sir.
Fine.
Yes, sir.
Okay, let's begin. So let's see what is GATE, how we will be handling these topics of GATE Aerospace Engineering. Okay. So our target is GATE 2025. A is the paper code for aerospace engineering. Every year it happens. Every year this paper will be happening in the month of February. So this will be happening in Feb 2025. So Feb 2025, it will be happening in the first or second Saturday or Sunday. Okay, next 2025 it will be happening. Every year it happens in the first or second Saturday or Sunday. Okay, so the number of expected participants in the GATE 2025 would be somewhere around 5,000 to 5,500. Okay, not more than that. Okay, the marks, again, the expected GATE 2025 would be in a more or less in the same pattern like it has been happening from past 8 years. Okay, prior to that it was slightly different. So it will be a 100 marks paper. Okay, the time allotted for the paper would be 180 minutes and it will have 65 questions. Okay, so these 65 questions will be divided, the entire paper is divided into two sessions. Okay, there will be two sections. One is called general aptitude, another is technical. Okay, so the general aptitude has 10 questions, 15 marks, and technical has 55 questions with 85 marks. So that is the heart of GATE Aerospace Engineering, the technical. Okay, so we will be teaching you each and everything, so no need to worry. Even the maths and general aptitude will be doing it in the beginning months itself. Okay, so this is divided again into question category like 1 to 5 will be 1 mark, and question number 6 to 10 would be 2 marks. Fine. And the technical session will have question number 11 to 35 will be 1 mark. Okay, or it will be mentioned like question number 1 to 25. It will be in that manner. Okay, sometimes they give continuation 11 to 35 or 1 to 25 again for this. This will be 1 marks, and there will be question number 36 to 65, or they will label it as question number 26 to 55. This will be 2 marks. So as you can see, this itself has 30 questions. So if somebody can do this questions 30 into 2, he will get 60 marks. Accurately only these questions. 60 marks means your rank will be in the top, all India rank 30. Okay, to get into aerospace, you have to have a nice focus. And from this, if you can get 10 marks, you will be in the top 5 ranking. That's it. simple it is. So the major focus should be to get this in your head and this to get into the top 5 ranks. Okay. So anyways, we'll do each and everything so that you can attempt 100%. Can I go ahead? Hope you all are through. A brief, I'm just giving a simple brief of this. So the question types, there are 3 type of questions. The first category is MCQs. Okay, means one answer correct. Then you have another category called MSQs. It can be one or more answer correct. One or more than one. So this, to crack these questions, you have to have a nice conceptual knowledge. Otherwise, this is the most toughest part. Okay. So then we have the third category called numerical answer type, in which you will be feeding the numerical value. You have to feed the numerical value in the blank. Okay. There will be a small tab. A palette will pop up. From that, you will click the numbers and you have to do that. And throughout the year, we'll be using the GATE calculator from now on. Okay. So the calci that they use in GATE, I'll share the link with you. You guys download that particular calculator in your, it is only available as of now for the Android, not for the iOS. So please download that. After the class, I'll share few links and all the books related to the GATE Aerospace. We will create in this week the whole folder for you, and different links as well as the books. Everything will be shared with you. So you please download, because there are a lot of books that you guys are not even having a clue of the names of the books. So many books are there which could be of the great help in solving the numericals and understanding theories. Okay. So how we will be doing our GATE syllabus. Okay. So GATE is divided into 7 typical verticals. Okay. So how we will be doing it, I'll list out that. So first, we'll be having Monday, Tuesday, okay, a subject, and then Thursday and Friday, another subject, okay. So these 2 days, that is Monday and Tuesday, we'll be beginning with fluid mechanics. We'll be beginning with fluid mechanics and aerodynamics. Today we are beginning with this. Okay. I won't ask you what is your name, from which city you belong and all that. You all came here. I really appreciate that. Okay. That is enough for me. You start giving answers. I'll ask your typically the names. Okay. There should be something, right, to remember the name. So these 2 days throughout will be, till we finish these topics, we'll be continuing on the fluid mechanics and aerodynamics part. Then the second subject that will be starting will be strength of materials and aircraft structures. For this, Krishna sir will be taking the class for you. Okay. Whereas this part I'll cover up. Then once this topic is finished, we'll be starting topic called thermodynamics and aircraft propulsion. Or before we begin the aircraft propulsion, we'll be doing thermodynamics. Then we'll pitch into a topic called gas dynamics. Because prior to aircraft propulsion, if you do gas dynamics, that will be wonderful to use the equations of gas dynamics in the propulsion. Okay. Parallelly, Krishna sir will be taking here the topic called, after he finishes the aircraft structures, he'll begin mechanical vibrations. Okay. Then once gas dynamics is finished here, We'll start here, the aircraft propulsion. Okay. And on these 2 days also, we'll be doing some other topic called rocket propulsion. Okay. Then we'll again have, once we finish these 2 topics, this would be in the later part of the course. Okay. That is after the rocket propulsion is over, we'll be starting thing called flight mechanics. Okay. So flight mechanics has a huge part. Okay. It has 2 verticals. One is called aircraft performance, and the other one is called airplane stability and control. Okay. And parallelly here, we'll be doing the engineering mathematics, or we will switch this topic in the beginning itself. We'll discuss with all of you in class and we'll be doing that. We'll see how is your mathematics. Based on that, we'll switch this topic in the beginning itself. Okay. Fine. Once this is through, then we'll go for the space dynamics. And once this is done, we'll be going for the final phase, general aptitude. Okay. So apart from some basic English, the quantity aptitude part and all we'll be doing. Whereas I suggest you guys use the simple small book which comes with solution also, Wren and Martin. I'll share the PDF with you. Those who have weak English, you start reading every alternate day, half an hour, Wren and Martin. That will bring very good English level to you. It's a like school book, right? So that is how we'll be covering up the things. Okay. So hope I didn't miss any topic. If I missed, we'll be having parallel to this, you will be having the online test series. Okay. Online test series comes with the complete solutions also, but still when you give a test, we'll have a discussion on the questions of the test also. Those some typical tough questions or some highly conceptual questions we'll be taking from some questions from test. After you give the test, we'll discuss it in class as well. It comes with the solution. If you don't understand any solution or step, you should report us and we will discuss that into the class. Okay. So for online test series, we have a separate portal. We will be creating that. So the online test series, we have a separate portal for this. You will be directed on our application called GATEJI. This is the app created by us. So there is an app called GATEJI. It's available on Android. You can download that. On that, test will be coming. So every 15 to 20 days, we'll be taking the test on different topics that you have covered, and we'll be doing your assessment accordingly. Okay. So try not to miss the tests, though they will be available till the end of the year. You should try to give it in the typical date range we will give you. Okay. So during that particular period, you should take the test so that we will be able to assess you properly, that what are your strong areas and what are your weak areas. Okay. And you parallelly, you make a habit of noting down each and everything. Okay. You should be writing your notes instead of we giving you, because we don't have a concept of sharing the class notes, what I am writing. Okay. So there will be no recorded things that we will be from previous years and all. Everything will be taught to you live. Each and every faculty will be teaching you live. So make sure you note down each and everything. And whenever you are having some trouble in attending the class, you should raise a request. We will send you the recording of the class. Okay. Fine, guys. So instead of talking about all the books. We'll begin today fluid mechanics, and every faculty, whenever they begin the topic, will be how we will be going in that topic. We'll discuss, as well as what are the references of that particular topic, instead of giving all the reference books in the beginning. No doubt we will share the whole folder with you in the beginning itself. Okay. So, but we will not be listing out each and every topic name and the books in the beginning today's class. So let's begin. Hope you all are fine. Shall we start GATE?
Yes, sir.
Yes,
Okay.
sir.
Fine.
Yes,
Let's
sir.
begin. Okay, guys. So let's start. Write a heading, fluid mechanics. Hope my writing is okay for all of you, though it's bad.
Yes, sir.
Okay, I'll try my best to write it neatly. If you don't understand anything, just unmute yourself and ask, and please mute again when you are not having anything to talk or speak about. Okay. Fine, guys. Write a heading, fluid mechanics and aerodynamics. So it has several subtopics under this. So we'll be beginning with the chapter, I call it as 0. Chapter 0, that is the basics of, instead of calling fluid flows, I call it as basics of aerospace engineering. Okay. Then we have chapter 1, that is flow kinematics. Then we'll be jumping to the next topic called 2D ideal potential flows. Every year, almost 4 to 5 marks is fixed from this chapter 2. Okay. Then the fourth is chapter 3. We have 2D complex potential flows. Then we'll be moving to the next chapter called conformal transformation. Though very rarely they ask things from these topics, but we will not ignore even one word that is there in the syllabus. Each and everything we must do. Okay. Because every time people used to think like they will ask 5 questions, 6 questions from propulsion. Last time they asked 14 questions from propulsion, thermo and propulsion. So don't predict when you don't have the ability to predict the paper, because IIT professors are highly unpredictable. What you will leave, most of the questions will come from that topic. Have this kind of mentality. Okay. Then we'll be going for thin airfoil theory. Okay. Then after finishing thin airfoil theory, please turn off your mics, ma. Again and again you have to. Okay. So after thin airfoil theory, we'll be moving to a topic called finite wing theory. Okay. A theory by Ludwig Prandtl, father of aerodynamics. Amazing theory. Okay. Then we'll be going to the next chapter 7.
Unable to
Can you hear me, guys?
Yes, sir. I can hear you. We can hear you.
Good.
Unable to see you.
One second. It will be visible. Don't worry.
Yeah.
Hope the screen is visible now.
Yes, sir. Screen is visible.
Okay. Till internal flows you noted?
Yeah.
Fine. Write the references. Okay. Whatever PDFs are available, I'll share with you. Only one book you have to buy, that will come at a price of around 260 rupees. You can buy it from the Flipkart or Amazon, but it's a must book. Okay. How many of you have a book called R.K. Bansal? Fluid Mechanics, R.K. Bansal. Do you have this book?
Yes, sir.
Throw it.
Yes, sir.
Okay, I'm saying it on the recorded line. Throw it. We don't need this. Okay. One of the worst books of fluid mechanics, which makes your entire destruction of the sign convention, is this book. Okay, R.K. Bansal, Fluid Mechanics. Do not use this book for our class. Okay. Hope that is clear. There are nice international and national books which we'll be referring to. So make sure you do that, because otherwise your sign convention will be so much damage that you will, throughout your life, you will be doing those mistakes. So you write Fluid Mechanics, okay, by author called D.S. Kumar. Amazing book. Okay, you will have to buy this book. Please buy it on Flipkart or Amazon. I don't have any connection with D.S. Kumar. I'm not promoting him. Okay, but it's a very good book. Fine. Next, you write 1000 solved problems in fluid mechanics. No need to buy this. None of the below books you have to buy. I'll share the PDF with you. Okay. We have the PDF of this by the author called K. Subramanya. Okay. Amazing book. If you can buy, that is, you can buy, but it is not required. The book is must, obvious. Then you write fundamentals of aerodynamics So there is a PDF available. Very nice PDF is available nowadays by John D. Anderson. I hope every one of you even have the hard copy of this.
Yes, sir.
Okay, fine. Then there is a book called, none of you would be having this book because when this book got, last print of this book came, that was the year I was born, that is 40 years ago. Okay. Aerodynamics for engineering students. Amazing book, guys. I'll share the scanned copy of this book. I have the original book. Okay. So in the entire Chennai, only 2 people have. One is in IIT Madras library, another original book gifted by my prof, Rajiv Roy, gifted it to me. So the one original book is there. So I have the scanned copy of this. Horton and
yes, sir. L. Horton, right?
Horton and Carruthers.
Yes, yes.
So in the
In our
beginning,
library
Horton
we
and
have that.
Carruthers book came. Can you turn off your mics, ma? Horton and Carruthers came. Okay. But after Carruthers passed away, Horton and Brook came for 10 years. And after Brook passed away, nowadays Horton and Carpenter is available. Horton and Carpenter PDF is available, but Horton and Carruthers, no one has it. Okay. So I'll share that scan copy of this book with you. No need to worry. Fine. Then the legendary book of fluid mechanics. The title is Fluid Mechanics only. So there is a nice PDF available for this by F.M. White. So even the J.D. Anderson refers this book at several places. Okay. So these are the references that are mandatory. Apart from this, you can do whatever books you have, and you can pose the question and ask the doubts, anything. You are free. At the beginning of the class, you can ask the doubts. At the end of the class or in the middle of the class, anytime you are open to freely ask the doubts. Okay. Fine, guys, let's begin. I'm beginning with the very basic things. Okay. So you write a heading, basics. So I'll be picking up some very, very simple basics of fluid flows. Okay. Then I'll go for different introduction to different parts. So what is a fluid, guys? Now you can unmute yourself and answer. What is a fluid?
That which can flow.
Sorry,
Deforms continuously.
That which can flow in a medium.
even the traffic can flow, no? Hope you heard traffic flows, lava flows. Typically, what is a fluid?
Yeah, sir.
Answer me, guys.
Sir,
Yeah.
sir, a fluid is a substance that can flow continuously. It shows continuous deformation.
So basically, you are missing one part. You are saying continuously flow. Okay. I can have a continuous flow of traffic, but I cannot call it as a fluid, right?
Sir, in intermolecular spaces, it will flow, sir, and it has no shape also.
No, not necessarily. Fluid can occupy the shape of the container itself. See, fluid is basically a substance which continuously deforms. Okay. But for continuous deformation also, you have to apply some stress. If you are not applying, like water kept in a water bottle, do you see continuously deformation happening? No, right? If you apply a small shear stress or tilt the bottle, the gravity allows it to flow. Okay. Or you blow some air on water and the shearing you will see. Okay. So when you apply the shear stress, the substance which is deforming continuously, that is what is called as fluid. So you mentioned, note, fluid is a substance which continuously deforms on the application of shear stress. Parallelly, you make note of each and everything, guys. Okay? On the application of shear stress. I am writing this, but I will not share these notes with you. You have to write. One time writing is equivalent to 7 time reading. Okay? So you write a heading. Next, what is a substance? Substance can exist in multiple phases. Typically, it is divided into 2 phases. One is called as solids. Another is called as fluids. So in solids, we have very strong intermolecular bonding compared to fluids. And fluids, we can further divide the fluids into 3 more categories. Okay, we have to have a strong knowledge of all these 3. Not necessarily the plasma, but first 2 is mandatory. Okay, so you write liquid, gases, and plasma. Okay. Abraham, turn off. Write a heading. Solids. Okay. Write solids. Right. In solids, strength of force of attraction between particles is very strong. Okay. Next you write, they are closely packed, meaning the particles are very closely packed. On motion or application of force, solid particles solid particles vibrate about in a fixed position or positions. Okay. And they are arranged in a regular, or you can say structured manner. Okay. So I'll just show you how they are arranged typically. Particles in solids are arranged in regular or orderly manner. In bracket, you write structured. Okay. Just let me give you a glimpse of how the particles would be arranged in that. So usually in solid structures, you will have solids. You will have arrangement something like this. Okay. For example, you can map this. Hope you can see the pattern. They are arranged with almost of constant or fixed intermolecular distance. Okay. Hope that is clear. You can say this is a triangular formation, or if you take only these, you can say hexagonal arrangement is there. Okay. Like that, you can have not necessarily always just the triangular or hexagonal. You can have split this into the whole thing into this kind of category as well. Okay. For example, you can have so typically using this, different meshes can also be formed. And you can say that at every node you have a particle, but that is not mandatory. So if we apply the force, they will vibrate about their own position. Okay. Can I go ahead, everybody?
Yes, sir.
Okay. Write a heading, liquids. Right. So in liquids, strength of force of attraction between particles is strong, but in bracket you write, but less than solids. They can actually do intermingling from one region to another region. Okay. I'll show you the animations after this. First, you just note it like that. And in this, there is no order. Arrangement of particles is random. Okay. So you write arrangement of particles is random. Okay. But closer than gas. They are also closely packed, but further apart than solids, obviously. On motion, particles slide or roll over one another. Okay. Next point you can note, they can intermingle. Why I'm beginning with this kind of thoughts, you will understand a little later. Okay. Why these are all important when we talk about the viscosity and all that. So the particles you can see in this image, they are intermingling. Okay. So they don't have proper structure. They are in an unstructured manner. Okay. Then, right, let's move on to the next thing called gases. So gas is a type of a fluid which occupies the entire shape of the container. Okay. So however small quantity of gas it could be, entire control volume it can occupy. Okay. So you write first point, strength of force of attraction between particles is very weak. Okay. Arrangement is obviously random. Or you can say disordered. Okay. Far apart from one another. Okay. And in this, the particles can move around freely in random motion. Okay. Next, you write note on motion, particles will excite. So there is an energy of excitation also. They will excite far apart with no regular movement. So anyways, let's look at the last part of it. One second. So the gases randomly, you can see one particle here and the other. I'll in fact show you the animation of this. Okay. One second. Hope you can see the structure. So these are some, I am applying some force and the particles are vibrating about their own position. So which structure, what is this substance? If this happens, what you will say the substance is? Solids. Okay. Whereas, see this is a fluid which is liquid. The entire shape of the screen is the container, vertical. It's a square box. But the liquid, when I apply some force, it's not occupying the entire shape of the container. Up to some height only it has occupied. And when I apply some force or shear stress, they are deforming and they are intermingling with one another. So what is this? What substance is this?
Fluid.
It is a fluid, but it is a liquid category. Okay. You cannot just say fluid. Okay. It has to be a liquid. Fine. Now you see this. The particles are going in random motion in the container. So what are these?
Gas.
It is a gas. So all gases will have this kind of behavior. Fine. So when coming to the last part, okay, you note plasma. So what is plasma? Suppose I have a small control volume like this. For example, I take a simple control volume of this category or this kind of control volume. We draw a simple control volume. And you have the substance present here is with some plus, minus. So what are these plus, minus? They are ions. Okay. They are the ions. So you have free ions and free electrons. Okay. So when this is possible to have, when there is a ionization. Okay. So the formation of ions and all. Okay. Molecules will break and exist and leave the ions. So when there is a ion formation, the whole field is filled with that particular substance is called as plasma. So plasma is field of free electrons, which we showed with minus, and protons, which we showed with plus. Hope this is clear, everyone. Can I go ahead?
Yes, sir. Yes, sir.
Fine. Write a heading, viscosity. What is viscosity to you? I am assuming you all are just 12th
Sir,
pass.
excuse me.
Yes, ma'am.
Yeah, sir, there is a doubt like this regarding this plasma. Can you say any example? Like any real life example is there?
Yeah,
Can
there are a
relate
lot
it.
of examples. Like, see, for example, this is our Earth. Okay. And we have the surrounding atmosphere, right? What is atmosphere? Atmosphere is a layer of several layers of gases. Okay. So,
Okay.
so the atmosphere in which we are living now is we are in the troposphere zone, right? On the Earth's surface, and we commercial airliners, they all fly slightly within this range or mostly in this troposphere range. Okay. So we call it as tropospheric region or troposphere. Fine. Another layer above this would be like stratosphere. Okay. Above the troposphere comes the stratosphere. So this region we call it as stratosphere region. Okay. I am coming to your doubt. Okay.
Okay.
So between the stratosphere and the troposphere, we have a layer which is making our Earth survivable. Okay. Avoiding all the infrared rays, reflecting the unwanted ultraviolet rays, and allowing only the needful ultraviolet rays. Okay. So that is called ozone, right? So here is our ozone. Now, above the ozone, the sunlight, suppose this is the sun, and you have a huge sunlight. So, lot of sun rays. So, you must understand that incoming sun rays, they don't heat up the medium. Okay. The surface first gets heated up, and that heat dissipated from the surface heats the medium. Okay. So, through radiation, the energy transfer from sun to earth takes place. Okay. So, there are, as you start going up in this region above the ozone, see, the stratosphere is divided into two parts. One is above the ozone, another below the ozone. Hope you can see that.
Yeah.
So above the ozone, it is called upper stratosphere. Below the ozone, it is called lower stratosphere. Okay. So once you go above this strato or beginning of this, the outer fringes of the stratosphere, you have a region here. Okay. You have several other layers called ionosphere, thermosphere. Okay. And then you have the exosphere. And the collection of those three, some part of the stratosphere, some part of the mesosphere, some part of the thermosphere together is called ionosphere. Okay.
Okay.
So in this region, you will not have, so you don't have the full molecules. Okay. The molecules will split into the ions, and they are called as typically the plasma. Fine.
Okay.
So that is the most simplest example I could present now. We will be having huge when we do the combustion. Once you understand the chemistry of gases, then we'll talk about the combustion. Okay, that won't be a suitable example at the beginning. That's why I took the real life example called ionosphere, in which you'll have rarefied gases and the plasma. Okay?
Okay. Fine, sir. Thank you.
Fine. Okay. Let's go ahead. Write a heading, guys. Viscosity. So what is basically viscosity? So it is a property actually, not something like which will be produced. It is the property, means it is inherently there in the fluid. So it is the property of a fluid which offers resistance to motion. Okay. So you want to move through the fluid. It is the property called viscosity which allows the resistance to move forward. Okay, which offers obviously the shearing nature and produce the viscous tractions and give you the viscous drag called shear drag or skin friction drag. Fine. So right, it is the property of a fluid. It is the property of a fluid which offers resistance to motion. Okay. So very commonly we denote this with a coefficient of viscosity. So we have it like parameterized as we measure it with this coefficient of viscosity, and it is most commonly denoted by a symbol mu. No doubt mu is used in several other topics with some other symbol, but in fluid mechanics we will be referring to this as, suppose anybody know the units of this coefficient of viscosity? What are SI units for this coefficient of viscosity? Anybody?
Pascal second.
Sorry?
Pascal second.
Very good. It is Pascal second. Okay. So sometime in paper, they will give you like this: kg, meter inverse, second inverse. Is it correct or wrong? This unit that I wrote.
Correct, sir.
Correct, sir.
It is correct. Okay. So very commonly you should remember it as Pascal second. Or you can say Newton second per meter square. Pascal is Newton per meter square, right? 1 Pascal equal to 1 Newton per meter square. Okay. So this mu is also called as molecular viscosity. Or some authors, they prefer calling it as dynamic viscosity. Make a note, guys. Can I go ahead? Hope you all noted this, everyone.
Yes, sir.
Okay. So there is a other variant of this. Sometime instead of giving the viscosity and density separately, they give the parameter kinematic viscosity. It is denoted by the symbol nu. Okay. It's simply nu is equals to mu by rho, where rho is the density and mu is the dynamic viscosity coefficient. Okay. Let's label this one as equation 1. In basics itself, we will be having somewhere around 100 equations, guys. So we are beginning with the first one. The units of this, anybody? See, the units are very, very important. You have to be always careful with the units. Anything we do, we will never leave the units behind. What is the unit, guys?
Meter square per second.
Very good. The units is meter square per second. Keep that in mind. Make that as your habit to remember all those things. Okay, let's begin. Some other things like relative density. Relative density. It is simply the relative density is simply it is denoted by the simple sigma. Okay. And it is the ratio of density of the fluid to again density of the fluid. Okay. But what is this rho naught? This is density rho at altitude h. Okay. Whereas this is the density of the fluid at mean sea level. MSL stands for mean sea level. So we consider mean sea level h is equals to 0, where the altitude is 0. You call this as equation number 2. Call it as equation number 2. Hope you are through, everybody. Can I go in?
Yes, sir.
Okay. So let's see what is a chord line. So obviously chord line, what is a chord line, guys? Anyone?
The
It's
line,
a line joining the leading edge and
the line joining the leading and trailing edge of the airfoil.
Okay. If I don't have an aerofoil, I didn't ask you chord line of an airfoil, right? I simply asked you chord line.
Line that connects.
So
If
the
I-
line that joins any 2 points on a circle.
Not necessarily on the circle, ma. It can be any curve. Okay. Fine. So if I make a cut like this, what is this? If I make one line at these 2 points, it is cutting. It is intersecting at these 2 points. What can I call this line as? Chord.
Chord like.
Simply, this is a chord line. Okay.
Yes.
Can I go in? Or you can say it is a secant. Fine. You can say a secant or a chord line will be like this. So you write next, you write chord. When we say chord line of an airfoil. Chord line of an airfoil. Yeah, you guys were saying something. Please say that. What is an chord line?
That which connects
The line joining the
leading
trailing
edge and
edge and leading edge of an airfoil.
Line joining the leading edge and trailing edge, right?
Trailing. Yes.
Everybody?
Yes, sir.
Okay, let me take some nice airfoil. Fine. Okay. Is this the chord line or not? Is it the chord line or
Yes,
not,
sir.
guys?
Yes, sir, chord line.
Chord line? Okay.
Yes.
Let me
So
take another.
what is an airfoil?
Aerofoil. Aerofoil is a streamlined body. Okay. Aerofoil is basically aero. So the word came from air, mostly the airflow around it. So we say aerofoil or we say airfoil. Okay. So aerofoil or airfoil is a terminology which is used for the bodies, streamlined body like one of the airfoil I'm showing you here. There are thousands or millions of shapes for different category of airfoils. Millions of aerofoils are available. So a streamlined body meant to reduce the drag is basically an airfoil. Okay. So prior to airfoil, the hydrofoils were developed. Okay. Before the airfoils, people had developed the hydrofoils. Hydrofoil basically is a foil which is hydro, means water, underwater. Fine. So to make the usage of the lift production by the hydrofoils and reduction of the net drag on the body, they developed the foils called hydrofoils. Then when the aviation industry started evolving, they started using this kind of cross sections for the wings, and they started making the wings like this. Okay. So they connected and they made the wings like this. Hope I made it clear. How a aerofoil got developed, we'll study that in a concept of streamlining. I will go in detail after a little while. Okay, you just hang on. Hope I gave you a small brief idea what is an airfoil. Okay,
Okay, sir.
fine. Now, let's say I have an airfoil like this. Let me take some typical airfoil. 1 second. Let me choose a typical one. We'll take one of my favorite airfoils. Okay. I hope I have that. Okay. Yeah, there it goes. So let's say I have a nice airfoil. So I'm joining this and this. What is this line, guys? What can I call this line as?
Port line.
Okay. Are you sure about this? If I join this and this, what is line 2? From here to here, no doubt, obviously. From the leading edge to the trailing edge. So the front edge is called leading edge, right, of the airfoil. We very commonly will be denoting in the short form LE throughout the course. And this part, the last end, is called as trailing edge. We'll be denoting it with T. So we have a nice shape called airfoil. Please tell me which one is the chord line? Someone? You all became very quiet. Why is that? You don't know chord line?
Confusion.
Sorry?
We have
Seems
confusion
to be both are caught.
with the screen.
Both are chord
But
lines.
we can, yes, sir, we can say both.
No. See, obviously if I measure this distance and the other distance, okay, this distance and this distance, both will be giving me some difference, right? Both are of different inclination. So both will be having different lengths, obviously, right? So if you say so, if I draw one more line like this, slightly below this, or let's zoom it in, and I draw one more line, third line here, okay? And I say I want this one as the third chord line, okay? You will say again, sir, this we can have 3 chord lines like this. No, you cannot have that, because there are many design points which lie on the chord line, okay? Based on that chord line, every other design parameters work, okay? So you cannot just be cannot be sure about which one is the chord line. You have to be sure what is your chord line. Then you measure that chord length and you will find the planform area, or you do the analysis like thin aerofoil theory, formulations, and all those things. Okay. So let's remove the headache from this. Okay. Let me consider this. So this brings in a confusion, right? So it is bringing a confusion like which one is my chord line. So let's get rid of that particular confusion and give you absolutely what it is. Okay. So what one can do is, if I have 3 points, connecting these 3 points, I can draw a circle like this. Agree? Any 3 points. Okay. Or I can take 2 points and the distance between these 2 points, and I can sweep, rotate it, and I can form the 2-point circle. Hope that is clear. Everybody?
Yes, sir.
Yes, sir.
So there are different ways of drawing the circle. So if I can get 3 points in the leading edge, so I'll be taking some 3 points on the very leading edge, 3 points. So using these 3 points, I'll draw a circle like this. Hope that is clear. I'm teaching you design part. How do we be sure about what we are doing? Okay. So this will be having a center of this nose radius circle. So this is what is called as nose radius circle. Okay. This is a nose radius circle. And here literally I'll call this as Rn. Rn is the nose radius. So the supersonic aerofoils will be sharp at the leading edge. So the nose radius is 0. You don't have the nose radius circle in a supersonic foils. Supersonic means more than Mach, the aerofoils which are used for more than 1 Mach number aircraft. Okay. So the characteristic of supersonic aerofoils will be, they will be mostly symmetric and they will be having sharp leading edge. Okay. So you have the nose radius circle. Now, if I join so there will be a point which will be at the leading edge, which you can mark somewhere here at the center of this curvature. There is this small curvature, right? So the center of this curvature, you will mark a point. Okay. Then you will draw a line passing through this point. Usually it passes through the center of the nose radius circle also. This line, which you are seeing, which passes through the center of the nose radius circle and cuts or intersects the leading edge curvature. Okay. This line is called as chord line. Draw this, everyone. So chord line is a line. Now there cannot be other line like that, right? It will not be passing through the center of the curvature, nor this, neither this one, nor that one. None of them are passing. There can be only one line like that. Hope this is clear, everybody. Hope you all are through.
Yes, sir.
Okay, fine. I am assuming that you guys don't know aeronautics at all. Okay. You are
Sir,
yes, ma. Go ahead.
sir, this nose radius circle, right? You drew it by taking 3 points, right?
Correct.
Yeah. So these 3 points, you just assumed it like that, or is there any parameter to take those?
No, you can pick up any 3 points on a curve. Okay. If you have
that is the case, then you can draw it maybe below also, right? So then your chord line can change.
No. Those points have to be on the curvature, right? Leading edge curvature of the aerofoil. You already have an aerofoil. It's not that you are drawing the aerofoil. You have the aerofoil, you want to figure out what is your chord length. For that, you need to know chord line. Hope that is clear.
You're drawing it exactly on the leading edge, wherever is the curve.
Correct. I am picking up the points on the leading edge curvature, 3 points. Okay. They can be, obviously you cannot take the point here and draw. That will not become a leading edge curvature, right? You might say, sir, why not you take a point here, and a point here. Joining these 3, I may not be able to draw a circle of that category. I will be able to draw a circle like this, which will not be giving me the nose radius. Hope you understand that.
Yes,
okay?
Sir.
Fine.
Sir, please repeat this concept again.
See, what I am doing is I am taking 3 points in the leading edge. So I'm using 3 points, I can draw a circle like that. Hope that is clear. Okay?
Yes.
I am not picking up the points randomly anywhere and drawing a circle. At the leading edge, I am picking. Okay? Fine?
Yes, sir.
Hope that is clear, everybody?
Yes, sir.
Okay. So this, now the distance, not between the centers, the distance from the leading edge to the trailing edge. What is this called?
Chord length.
Very good. Chord length. We will be denoting throughout the course with this small c, chord length. Okay. The distance between the leading edge and the trailing edge, we'll be calling it as chord length. Okay. Write a heading, camber line. Okay. Write a heading, camber line. Let me take this. Anybody know what is a camber line, guys?
It's the locus of the midpoints between the upper surface and the lower surface of the airfoil.
Very good. It is the locus of the midpoints between the upper and lower surface. Very good, man. Nicely stated. Keep it up. So,
and perpendicular to the camber line.
No. Now you are going in a wrong direction. Previously, you were right. I will elaborate why you are wrong there and why you were correct before. See, I want to know what is the midpoint between the upper surface and lower surface. Okay. Please turn off your mics, ma. There is a disturbance continuously. Okay. Let me do this. So I want to know exactly the midpoints. So how do I find a midpoint between the upper surface and lower surface. Let's take a point here and a point here. If I find the midpoint of this, do you mean that this point which I have marked with a cross will lie on the camber line? Answer me, guys. Do you think it will lie on the camber line?
No.
Might not.
Not necessarily. Okay. Same way, we can have a point 1 and a 3 and mark the midpoint somewhere here it will come. Then also we are not sure. Then how do we locate the camber line? Okay. Becomes an issue. So what we do is, see, observe this very carefully. I'm teaching you the aircraft design process. Okay. Now, you have already the nose radius circle. Then you will draw a circle. Okay. You will draw a circle which will touch the upper surface, lower surface, and the previous circle. Same thing you will repeat till the end. Because you already have the shape of the airfoil. You are not going to worry about drawing the shape of the aerofoil again. You just need to figure out for this shape, where is my camber line going? Okay. So how you have to draw these circles? You have to fill the entire domain like this. Okay. The previous circle, the upper surface and the lower surface. The circles touching like this. Fine. Keep drawing that and fill the entire domain with circles. Hope you all are through. Everybody? Draw very neatly, guys. I'll tell you, Matt, why I stopped you when you said perpendicular, right? Anyways, I'm just drawing slightly rough circles in this zone. Then it will become like a point at the end. First, you all draw this, fill the whole domain like this, everyone.
Yes, sir.
Hope you could do that. Then you mark the centers of these circles. Mark the centers of these circles. Hope you could do that, everybody. Except the first center, join all the locus of all these centers. Do that. One second, let me take some other color. You will be getting some line like this. Hope you are able to draw a line which is the locus of all these points, everyone. This blue line in my case. Okay.
Yes, sir.
So this green line which I have here is what is this green line we marked? It is chord line.
Clearly.
And this blue one for us is the camber line. So it is the line which divides the upper half, the aerofoil, into two equal halves. Okay. They will be exactly equal halves. Hope it is clear.
Yes.
Now coming to another important part. If I draw a tangent here, for example, anywhere throughout, this actually should come slightly here. Maybe I didn't mark the point properly. So now, if I draw a tangent at any point on this curve, okay, any damn point I want, I can draw a tangent like this, right? At some point, I'm drawing a tangent. You draw that. Hope you can draw a tangent like this. A small tangent you draw at some point. Let this be that point. Hope you made a tangent like that. Now, from this point, you measure this distance above this point. You'll call this as YU. Below, you will call this as YL. YU is equal to YL in magnitude. Mod of YU should be equal to mod of YL. Means the distance above should be equal to distance below. You have that line will divide into equal halves. But you observe this YL is not, neither the YL nor the YU is measured perpendicular to the chord. Hope it is clear. Hope it is clear, everyone.
Yes, sir.
Okay.
Can you just repeat? You said it's not perpendicular to the cable line.
See, these two distances are measured perpendicular to the tangent that I made on the camber line.
Okay. Okay.
So these two are perpendicular to the camber line, tangent to the camber line. Is that clear?
Okay.
They are not perpendicular. See, this angle, you observe this angle is not 90 degree.
They are not
angle
perpendicular to the chord. That's what you said.
Correct.
Okay.
They are not perpendicular to the chord. Chord is our green line, right?
Okay.
That's why I'm using different colors as well. Okay. Now, so we have here, okay. So what we have here is the word that somebody said is camber line is a line measured perpendicular to the chord. It is not camber line. It is the camber. Okay. So I can measure camber here perpendicular to the chord. I can measure camber here. I can measure here. Throughout I can measure, but it must be measured perpendicular to the chord. So what is camber? Camber is at some distance from the any point. I can, at some x distance, I can measure the camber. Okay. So this is what is called camber. Camber is the distance measured between the chord line and the camber line. The two perpendicular to the chord. Is that clear to everybody?
Yes, sir.
So camber is the distance measured perpendicular to the chord between the chord line and the camber line. Please note down that. It's very important aspect. Okay. So you please note down that camber line divides. First you note this. Hope you all made this, everybody. Okay. Hope you all made this drawing.
Sir, our focus is on the understanding on right.
Can we go ahead, guys?
Yes, sir.
Yes, sir.
Okay. Right. Camber line, note down. Camber line divides the airfoil. You can say airfoil or aerofoil. It doesn't matter. AERO or AIRFOIL. Shape into two equal parts. In a philosophical way, if you would have asked me what is airfoil, I would have said the heart of the aircraft. Wherever you cut, typically, majority of the times you get the aerofoil shape. You take the cross section of the wing, you get aerofoil shape. You take the cross section of the flap, you get aerofoil shape. You take the cross section of the rudder, you get aerofoil. You take the cross section of the elevator, you get airfoil. You take the cross section of the propeller blade, you get the aerofoil. You take the cross section of a compressor blade, you get the aerofoil. You take the cross section of a turbine blade, you get the aerofoil. You take the cross section of the guide vanes, you get the aerofoil. So it's like it is the heart of everything. Okay. So you will find aerofoil everywhere. That's like philosophical aspect of it. But aerofoil is nothing but a streamlined body designed to reduce the overall drag produced by the body. Okay, a streamlined body. Right. So camber line divides the airfoil shape into two equal parts. It is the locus of centers of the circles shown in above figure. Shown in above figure. Hope this is clear. Write a word, camber. Normally we denote it with capital C. Okay. So the things, the red lines which I am showing here, so they all are perpendicular to the chord line. Hope this is clear. Whereas YL and YU are perpendicular to the tangent. And this is perpendicular to the chord line. Okay. So you write, the screen is visible to all of you?
Yes, yes.
Yes, sir.
Okay. Please note down this. Camber. Camber is defined as the distance between chord line and camber line measured perpendicular to the chord line. Okay. Or I could rephrase this same sentence as the transverse distance measured between camber line and the chord line. Okay.
Could you repeat?
Praveen, turn off your mic. We can also say it is the transverse distance between the chord line and the camber line measured perpendicular to the chord. Okay. You note this. That should do. Okay. Fine. Can I go ahead, everyone?
But the length of camber is vary from leading edge to trailing edge, sir.
What?
The length of camber is vary from leading edge to trailing edge.
It will be varying, obviously. Yeah, it is a variable. That's why we say camber distribution. ये जो दिख रहा है ना आपको इतने सारे, all these what you are seeing, they all are different cambers. Understood? So among them, one will be the maxima. उसका नाम होता है maximum camber. Let's say that is here. Let this be the C max. That is maximum camber it is. ये unique होगा. This will be unique. That's why maximum camber location you will find out like this. From the leading edge, you will measure the location of maximum camber. X C max, what we call it. अभी जाएंगे हम लोग detail में. We'll go in detail little later. Don't worry about it. Okay. Can I go ahead, everyone?
Yes,
Yes, sir.
Okay. अभी तो शुरुआत है यार. अभी छोटा. We are learning ABC of aeronautics. Okay. So don't worry about it. Okay. Fine. Let's go further. Now I'll extend the understanding of this aerofoil to something else now. Okay. We'll be doing nomenclature of different airfoils, the family of aerofoils and all that little later. Okay. Let's take two airfoils typically. Okay. Let me take two airfoils for you. I have done huge work on aeronautics and you all are most welcome to, you are my 109th batch, guys. You all are 109th batch. And tomorrow I'm starting my 110th batch of my career. So till now we have taught in PATHSHALA more than 9,000 plus students or around 10,000 students here. Okay. So welcome to the big family of, we have a huge alumni association of PATHSHALA. 58 students are scientists, or 55 are in DRDO and 3 are in ISRO. Okay. And some are in CSIR also. Fine. So it's a big family. PATHSHALA alumni association itself is a huge. I founded PATHSHALA, me, Jagmohan. We founded the PATHSHALA in the year of 2007 or 2008 actually, but we started teaching in the year of 2007. So it's been a long journey. So do not hesitate to ask any doubts. Okay. We will try our level best to answer all your doubts and we'll put all effort to get you every possible solution. You try to bring questions from any place you like. Okay. we will try our best to give you all the answers to those questions, and we will be giving you huge. Okay, so it's like roughly around in this course we will be solving somewhere around 4,000 numericals, guys. So pull up your socks. You are in a big place now. Okay, you also have to work very nicely. In class itself, we'll be solving around 2,000 numericals. So be ready for a big change. Okay, you cannot be a lazy bone sitting in the corner of the room looking at the screen. Okay, you have to parallelly work to become an IIT. Okay, anyways,
Sir,
yeah, say something.
how much, sir, rank is required to join ISL or IIT?
क्या बोल रहे हो?
How much rank is needed to join ISL or IIT college, sir?
What rank you require? What range of rank you're asking to get into IIT? Okay, see, I'll talk
Yes.
about this. If you are in a general category, okay, open category, your rank should be somewhere. Nowadays, we have huge number of seats since last year. Okay, so previously there were only 15 seats. Now they made it 48 seats in IIT Madras. So it's huge. Okay, and IIT Bombay has 49 seats, and ISC have 22 seats. Then IIT Kharagpur has 52 seats. Okay, so all up together, you require for open category somewhere around, your rank should be below 170 All India rank. Okay, below this. Fine. Some people get it up to 200 rank also, they 230, 240 also they got, but that will come in the spot admissions. I'm not talking about that. If you are OBC, okay, some IIT like, for example, IIT Guwahati also has aerospace under mechanical. So last year, our own student Venkat, he got offer letter and he joined as well into the IIT Guwahati. So his rank was around 670. Okay. But good IITs, your rank should be, even if it is OBC, your rank should be below 240. Okay. It should be, if you want a good IIT. And you have a OBC category, that to non-creamy layer, NCL. You should, if you are having an OBC certificate, make sure it is a non-creamy layer mentioned there. Otherwise, you will fall in the category of open category. Okay. And if it is SCS and ST, this is like a Brahmastra. Okay. आप बस छोड़ो, qualify करो, आप IITian हो. Okay. So you just have to qualify. मतलब 900 भी ला लोगे. Below, above 900, usually they disqualify. Okay. So इसके नीचे होना चाहिए. Fine. Less than 900. Fine. NT. You just need to qualify. NT comes for national tribes. Okay. So I hope I answered your question, whoever was that. Okay. Guys, exactly at 8 p.m. every day, we'll be having a break. If I forget, because while teaching, it's my habit that I will go deep into subjects and sometimes I forget to give the break for 3 hours. Okay. My habit is like that. I will, if it is aeronautics, I cannot stop myself from talking so much. Okay. So please give me a reminder every day. So 8 to 8:20, I'll give you a break. Okay. Hope that is fine. This much break is enough. You can go and grab your dinner and come back. Okay. After the class, you can finish it off. Fine, guys. Buy some tiffin box if you are in a hostel. Okay.
Yeah.
Fine. You have to do that. You have to sacrifice something to get something, right?
Yes.
Fine. So you all rush and bring your food. I'll be catching up with you on the same link. I'll rejoin. You can also leave the link. Okay. You can exit the meeting and rejoin with the same link, guys. No other link will be shared for that. Same link will work on. Okay. Hope this screen is visible to all of you. Everybody?
Yes, sir.
Yes, sir.
Chal, we'll do some nice artistic work now. Step by step we will do. You can all please turn off your mics. That make that as a habit. If you don't have to speak, don't say anything. Okay? So write a heading, wing plan forms. So when you say plan form means top area from the top view. What you see from the top view. Okay? So let me take another template. Fine. Write a heading, wing plan forms, and draw one nice dot lines, not the solid line. Hope you made that, everyone. Okay. So first draw a rectangular plan form, guys. Draw a rectangular plan form like this. Please turn off your mics, again and again. I'm saying the same. Draw a rectangular plan form. This one is a rectangular plan form. Okay. No problem with this because here you have the chord length C, which you can label it as C bar also. C equals to C bar in this. Okay, this is your chord length. Fine. And this distance, the distance from one tip of the wing to the other tip of the wing is called wingspan. This is B. No problem. You have the planform area. S is called as planform area. So this S you can write as. So you have the wing planform area like this. Hope you all are through. Everybody? Can I go ahead?
Yes.
So S is the wing planform area. Now the problem will arise the moment I draw other shape. Okay. Hope you made that. Now this is a trapezoidal wing. Okay. I have now a trapezoidal wing. Now there is a big problem. B is same for this wing as well. This is the span. One tip to the other tip. Okay. Or I'll draw the other one. Let me draw this. So the distance from this tip to this tip, so tip to tip distance, this is what is your wingspan. No problem with the span. It is B. Okay. But there is a problem with this. Here you have a tip chord. Okay. You have a tip chord, which is CT, and you have a root chord, which is CR. Fine. This wing is called as tapered wing. It is called as tapered wing or trapezoidal wing. Hope this is clear. So there is a ratio. All trapezoidal wings or tapered wings will have taper ratio. So the taper ratio is denoted with a symbol lambda, which is the ratio of tip chord to root chord, CT by CR. Okay. For all tapered wings, the taper ratio is always less than 1. Okay. For a rectangular wing, what will be the tapered ratio for this wing? What will be the taper ratio for a rectangular wing?
1.
Correct.
1.
That will be 1. Then let's move on to the next wing. But there is before we move on to the next wing, we have a big problem, right? What is the big problem? What is the big problem is how do we find this planform area S. Because throughout our life, we have been writing the formula of lift as half rho V square S CL is the formula of lift. And this S is the planform area. And we were writing B into C bar, right? Here also we'll write B into C bar. What is this C bar? So this S is having this B into C bar. And this C bar is nothing but the mean aerodynamic chord. Or you can write MAC, mean aerodynamic chord. Hope this is clear. So we will find the mean of this. How to find and all, we'll see this after the basic shapes. Can we go ahead? I'll show you how to figure out this. So the problem is not with B, the problem is with this C bar as of now. Okay. In some cases, the B effective also you have to find. Guys, can we go ahead?
Yes, sir.
Yes, sir.
So this formula L is equal to half, is it P or
Half rho V square SCL.
half rho?
Yeah, I'll come to that. Half rho V square.
Okay.
Rho is the density, V is the velocity, S is the planform area, CL is the lift coefficient.
Okay.
Okay. I'll come to that. Don't worry about it. Okay. We'll in fact derive this in some scenario. Okay. Now, let's go to the next one. Let me pick up the next shape. Okay. These all are, I made this before the class so that it will become interesting for you. Okay. Draw this. This is a, what kind of wing is this, guys?
Swept back.
Swept back wing. So a wing which has the sweep back angle is called as a swept back wing. So this is a swept back wing. What is a sweep back angle, ma? So here I am having a sweep back, but I also have a tapered wing. Okay. So I am having here CT and I am having here CR. It is a swept back plus tapered wing which I have showed. So this is swept back, whereas this one is not having a sweep back. It is a tapered wing. What is a sweep back angle now? So in this case also we have to figure out what is C bar. Another problem. If we don't know C bar, we don't know what is S. Right? So the main root cause is this C bar. So we will figure out how to do that after you know the shapes. Draw this, everyone. So it is also having the taper ratio lambda equals to CT by CR. Tip chord divided by root chord, which is also less than 1 here. It can be equal to, so less than or equal to you, right? We can make like this also, right? We can do the sweep back just like this. Fine. I mean, we can have same CT, CR. Okay. Anyways.
So what is this swept back means? Is it that
I'll come to that. You draw the shape.
Okay.
Are you not from aeronautical background?
no, sir, I was from CS.
Okay, fine. No problem. I'll explain it to you how it comes. And in fact, I'll talk about something which all these aeronautical engineers also don't know. Okay. Don't worry about it. I'll tell you in detail. You keep asking like this, everything that you don't know. Okay.
Okay, sir.
Fine. Can we go ahead, everybody? Hope you made this shape.
Yes, sir.
I'll talk about this sweeping back in detail after this. Okay. One more shape I want, two more shapes, and then we'll go to the next ones. Okay. The next topic called sweep angles. Draw this one. This is a special case of sweep back. Okay. So generally sweeping back means making the leading edge go back like this. Okay. But this is not the sweep back angle all the time. I'll come to that. First you draw this. What is this? What is the name of this wing, guys?
Delta wing.
Very good. It is called as. So there is one nice lecture by me which is coming up on YouTube. It's called All About Sweeping the Wing. It's a more than an hour lecture. It will talk only about wings and the usages of sweep back wings. Okay, so you write CR. What is CT in this case? How much is CT?
0.
0. So what would be the taper ratio for this wing? 0. So a delta wing has a taper ratio 0. The taper ratio is 0 for a delta wing. Okay. So still in this also we have the planform area, right? This whole planform, the shape has an area, right? So for this also you can draw the span B and the span B here. So you have the span B, but you don't know still what is the planform area, right? Because in that also we write B into C bar. Why we write B into C bar when it is a triangle and it is a trapezoid? This is also a trapezoid. But still we write in all the time the planform area is equal to B into C bar. So again we need to understand what is this C bar. Without understanding this C bar, the whole game is of aeronautics is meaningless. Can I go ahead, everybody? Hope you noted that. Still, we have to figure out that. So there is some mean aerodynamic chord. We will see where it lies and how it comes. Okay. Let's go to the next shape. Now we are just worried about the different shapes of the aircraft. There are so many shapes of the aircraft. In sweepback itself, in my lecture, I have introduced somewhere around like 33 shapes of the wings. Okay. Sweepback wings alone. So anyways, we'll see that in detail now. Let's go to the next one. Draw the next one. See, a lot of people think that elliptical wing planform is something like this. Okay. It is not formed by the one ellipse like this. So this bottom part is part of one ellipse. This bottom part. Okay. It is part of one ellipse. The top part is the another part of the ellipse. Hope that is clear. Like this ellipse from here, if you cut and then make another wing, another part from the for the bottom one. So the combining those two, we will get the elliptical wing planform like this. So this bottom part here, this is one ellipse part, this is other ellipse part. So this kind of wing is called as elliptical wing planform. Hope this is clear. Nowadays, you don't see these kind of wings in aircraft, but during the World War II or before the World War, between World War I to II and after post the World War II also for a while, we used to have elliptical wing planforms. But the reference to all the drags is this wing planform. So among all the wings, the least induced drag is produced by this wing. That is the specialty of this. So what is induced drag? We don't know. So let's not worry about that now. Okay. Can we go ahead, everybody? Hope you got the names, shape and name. That is our interest. And what is the taper ratio for? Hope that is clear, everyone. Can I go ahead?
Yes, sir.
Okay. Now let's answer the question that was asked. Somebody asked, what is a sweep back angle? So you write a heading, sweep back angle. Anyone would like to answer this? What is a sweep back angle, guys? Anyone? Those who are aeronautical engineers.
It is a horizontal line.
Can you be little louder, ma?
It is a horizontal. It is an angle between horizontal line and the sweep. The line along the sweep between the angle. Right?
So the leading edge of the wing, you mean?
Yes.
I'll draw one angle, one swept back wing. You tell me. In fact, you all can draw this. Everybody draw this. So you want me to draw one horizontal line?
Yes, sir.
Should it? Okay. So instead of saying horizontal line, you should say lateral axis. Okay. Fine. This axis is called lateral axis. Okay. I'll talk about the axis system of the aircraft like this. This is the lateral axis and this is the longitudinal axis. Note like that, everyone. Let me reduce the size of this wordings because I need that particular part above. You make the axis also very clearly, guys. So you have the lateral axis and the longitudinal axis. So usually this lateral axis is denoted with the word Y, Y-axis. And the longitudinal axis is marked with the symbol X-axis. In fact, I can just extend this one over here and I can, you can also do that same. Oh, 1 second. Okay, you please mark this as the X-axis. Hope this is clear. Throughout the engineering, aerospace engineering will be using this notation. X-axis, Y-axis, Z-axis. Z-axis is the directional axis. Okay. Longitudinal axis is the axis towards the nose of the aircraft or towards the pinpoint of the wing, the most leading edge point. Can I go ahead, guys?
Yes, sir.
So if you cut the cross section of this wing, what do you get? Suppose I take the cross section XX. What do I get? I take the projection of this. What I'll get? A shape aerofoil. Okay, I'll get the aerofoil like this, or it could be like symmetrical aerofoil, or it could be sharp, doubly symmetric airfoil also. It could be thin, thick like that. It can be any one. Fine. We get the cross sections like that. Don't draw this. I'm just for the sake, somebody who don't know the cross section, I've just made that. Our interest is something else now. So there are, first of all, there are 4 or 5 sweep back angles. How many? 4 or 5 sweep back angles are there. If somebody asks you sweep back angle, give me sweep back angle. Okay. You should never say the angle between the lateral axis and the leading edge of the wing. Majority of the people fall in this trap and they say this is delta. So sweep back angle in general is denoted with a symbol incomplete delta like this. Note. Okay. Now let me draw first the tip chord and the root chord. Okay. So I'm marking here the tip chord first. 1 second. So I'm marking here the tip chord. So you mark that. Draw a tip chord. Okay. Then you come to this and mark the root chord also as well. So you have the tip chord and the root chord. This is your root chord, CT, CR. So you have CT and CR. Now you mark half of this distance here and you mark half of this distance here. So what this distance will become? CR by 2, CT by 2. Okay. Agree? Agree?
Yes, sir.
Draw a line at CR by 2. At CR by 2 point, draw one more lateral axis like this. Do that. Draw one dashed line parallel to the lateral axis. So that is your lateral axis again. So the primary lateral axis is this. And you can have secondary, tertiary, then fourth, like that you can keep on going. Okay. Hope you made that. Then draw a line passing through these two, like this. CR by 2, CT by 2. Draw one line like that. Okay. Then this angle between the lateral axis and the C by 2 line. This is what is called as C by 2 line. Half chord line also it is called. This is called half chord line of the wing or C by 2 line. So this angle is called half chord sweep. Okay. Half chord, see, it is going towards the back. That's why the sweep back name came. Okay. From the lateral axis to measure this angle, you are going back. So sweep back name came. Hope this is clear. It's called half chord sweep back angle. I'll mention that. Don't worry about noting down those things. Can I go ahead, everyone? Let's measure the angle between the lateral axis and the leading edge of the wing. So the leading edge is this, right? This is the leading edge of the wing. Leading edge of the wing. You take the cross section anywhere, you get the leading edge of the airfoil. Okay. Leading edge of the wing, you write. Fine. Now, the angle between the lateral axis and the leading edge of the wing is called leading edge sweep back angle, and it is denoted with delta LE. Okay. Post this, you mark. Hope you all noted that. Can I go ahead, everyone? Guys, can I go ahead?
Yes, sir.
Okay, fine. Now this is CR by 2, I said. Okay. This distance was CR by 2 and this distance was CT by 2. If I mark further half of that, it would be somewhere here, right? How much would be this distance?
CR by 4.
1, 4.
Correct. This will become CR by 4. So I'll mark here this distance as CR by 4. And what would be this? If I do half of it, this will become, oh, 1 second. It has shifted a bit. Let me just make it like this. So this distance will be CT by 4. Majority at times what happens is with the student is they don't know things and they start doing numerical. That is very, very weird and wrong also. Okay. So you first need to know what is aeronautical basic things. Then we will pitch into the topics. Who is who? You must know. Then we can narrate the story of the things. Okay. Hope you all mark that CR by 2, CT by 2. Exactly at, CR by 4 and CT by 4. Exactly at CR by 4, you draw another lateral axis, line parallel to the lateral axis. Do that. Okay. Then you draw a line which passes through CR by 4 and CT by 4. Do that. So what will be this line? This will be C by 4 line, which is very commonly in subsonic airplanes is also called as aerodynamic center line. Naam to suna hoga aapne. Okay. Can I go ahead? C by 4 line you call it. Hope that is clear, everybody. All these angles will be different, guys. None of them will be equal to one another in this tapered wing. It is tapered also, sweep back also. Very general wing I have taken, general sweep back. Then this angle you mark. This angle is called as delta C by 4, which is called as quarter chord sweep. Quarter chord sweep back angle. Then you draw, instead of marking at C, obviously there will be 3/4 chord, but it has not got any physical big significance. So we are ignoring the 5th angle. Rather, we are ignoring the 4th one and going to the 5th one. Okay. So you mark this angle At trailing edge, you draw the lateral axis exactly at CR from the first tip. Okay, first leading edge. You mark like this. This is delta T. This will be different from delta LE, obviously, due to taper. If the taper ratio is equals to 1, then delta LE, delta C by 4, delta C by 2, delta T, all will become equal. Hope that is clear. Delta LE is leading edge. I told you I'll be using this short form, leading LE for leading edge. It's called leading edge sweep back angle. Okay. Then I use the green color for the quarter chord sweep. So delta C by 4 is called as quarter chord sweep back angle. Then we listed out delta C by 2, that is half chord sweep back angle. Half chord sweep back angle. Okay. Then we went for, unfortunately, I used a white color there. I'm writing in black. Delta T. There will be delta 3C by 4 also, but it doesn't have a physical significance. So I'm not using that. Delta T is trailing edge. For that, I'm using TE. You better write trailing. Trailing edge. In future, I'll be using TE. Trailing edge sweep back angle. Hope this is clear, everyone. Can I go ahead?
Sir, can you show the picture once?
Sure. Okay. You can have a screenshot.
Okay.
Okay, fine. Let's go ahead. Now, let's see. Still, we got to know a lot of sweep back angles. Still, we don't know when they say sweep back angle, right? And it will be given in a numerical like 30-degree sweep back angle without mentioning which sweep back angle it is. Then you should take only the quarter chord sweep. So in general, it will be this one. In general, delta, when they say, okay, that is the sweep back angle. Sorry, sweep. So in general, when they say sweep back angle, it is the quarter chord sweep. Keep that in mind, guys. Okay, it is not the leading edge sweep, because most of the time you get habituated to saying this, the angle between lateral axis and the leading edge. Wrong. When they give you the sweep back angle, in general, it should be this one. Hope I made this thing clear. Okay. So still the problem persists. We don't know what is the C bar. The major crux of this problem is we don't know how do we mention what is the C bar, and why in almost every aeronautical engineering book they write the planform area as S into B, whereas length into breadth should be the area of a rectangle, right? So if it is B and this is C, it should have been a rectangle, whereas we are for triangular wing also, we are not writing half base into height. For trapezoidal also, we are not writing the summation of the opposite sides divided by 2 into height, right? Here also we are not writing. Only for rectangle, we are fine. We are happy with this rectangle that S is equal to length into breadth. Whereas throughout the life of aeronautical engineering, you will be using this formula S equal to B into C bar. Okay. So our main crux of the problem is figuring out what is this C bar. If we can figure out that, our life is easy. Can we go ahead? Necessity is the
Yes,
mother
sir.
of creation. So every time you learn something, you should always ask yourself, do I need this? When you need that, then you learn more. Okay. Can I go ahead, everyone?
Yes, sir.
Yes.
Okay. Our main headache we will hunt down now. Let me change the template. 1 second. थोड़ा मेरा writing सुधरेगा इससे.